In this video, we're going to have a look at using phase difference along with the speed frequency wavelength equation. So I'm sure you guys are aware that the speed of a wave is equal to its frequency multiplied by its wavelength. What I want you to also know is that one wavelength corresponds to a phase difference of 2 pi radians. What that means is if we have a wave here that goes like so, and we have a different wave, let's say in a different color, that starts exactly one wavelength afterwards, so it starts here, we can say that the phase difference between these two waves is 2 pi radians because they have a difference, a path difference that is, of one whole wavelength between them. Why that's useful is after you find the frequency, after you use the frequency and the speed to find the actual wavelength, we can then compare it to this distance. So let's do that. Step number 1, we're going to find the wavelength by rearranging this equation. So wavelength is equal to speed divided by frequency. In this case, that's the speed of 330 divided by the frequency of 256. I'm just going to very quickly do that on my calculator. And what we get is that that's equal to 1.289. 1.289 meters. But like I mentioned, that wavelength corresponds to a phase difference of 2 pi radians. So 2 pi radians correlates to 1.289 meters. What we want is the phase difference between 2 points, 0.16 meters apart. What we do for that is we take 0.16, we divide it by the fraction of the distance that's given, 1.289, and you multiply it by the conversion between radians and the distance. So that's 2 pi. And what you'll see is that that will be equal to, I'm just going to very quickly do this. So 0.16 over 1.289 multiplied by 2 pi. Approximately 0.78 pi. Or no, just 0.78 in general. And then from there, you want to put each of these into your calculator and see which one's essentially closest to 0.78. Because we did round it beforehand, there will be a little bit of a margin of error. But essentially, you're just looking for the one that's closest to 0.78. So pi over 8, after putting that in my calculator, I get 0.39. But after you put pi over 4, I believe, into your calculator, what you'll see is that it gives you 0.878 or 79, which is basically what we're looking for here. Again, because we rounded earlier on in the question, that's why there's a bit of a margin of error. So do be careful about that. But yeah, that's the main basis of this question. Be sure to leave a like if the video helped and subscribe. I'd appreciate a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.